So thank you so much for joining. Really, this is a session which is a session 2 of a series of sessions, and maybe there will be more. I mean, for now, it's 2-part series. The first session was a couple of months ago, where we have heard about trends in NewSpace, and we were focusing more on the economic impact. And I was talking to Adel the other day, and he will introduce himself as soon as he starts the presentation, saying that actually the whole movement to NewSpace, I mean, there's a huge economic shift when it comes to the satellite industry. And we said, well, it would be great to have an INSEAD community and some ongoing conversations around that. So we have created a Yammer group, which I suspect many of you, welcome, many of you are aware of. And we said, why don't we have a session where we talk about what does it mean for insiders or people attached to INSEAD in a tangible way. I mean, NewSpace is a concept on a macro level, but what does it mean on a business level? What do people do? So we were discussing with Adel, who has a really interesting story to tell. So we reached out to the community, and Lucy was kind enough to say that she's also willing to be part of this discussion. And so really what we're going to do in the first about half of this session, the 3 companies, Adel's companies, Lucy's company, and it's not my company, but I play a role in Tarides. We will each tell you what we do when it comes to NewSpace. Why is it important? What are some of the impacts? What are some of the problems we are solving? And the 3 companies are very, very different. So you should get a good overview of different aspects of NewSpace. And after that, we'll open up the floor for questions. So if you have any questions about what does it mean? What are potential use cases? What this may mean to INSEAD? Should INSEAD have a community for NewSpace? Those kind of things. We'll have another 45 minutes to focus on that. There are many people on the call, so I don't think it makes a lot of sense to go around to introduce ourselves. If you have questions, feel free to start your question by saying who you are, so that people who will be answering, and people really answering will be the 3 people presenting, will have the chance to respond. And with that, and Lucy, the order is Adel will start, you will go second, I will go third. Is that okay? So with that, why don't we start? And Adel, over to you. The floor is all yours.
Okay, let's hope it works this time. Okay.
You all can hear us here? Perfect.
We can hear you too.
Excellent. Thank you so much. So I mean, what you don't need, what you don't see, we have 5 people, actually 6 people at the offices in Tarides. We also have a guest of honor, Tomka, who is actually the founder of the company, who will listen into the first half of the discussion. I think, I'm not sure if you will be here to the end, but he was interested in understanding what people will be sharing. So,
can you confirm you're seeing my slides?
Yes.
I think good. All right, thank you. So I'm Adel Haddoud, INSEAD MBA D07. Infinite Orbit is essentially an INSEAD story. I'll explain that a bit later. What we do is we design, build, own, and operate assets in space to sell services to satellites who are already in space. If you see my mouse, typically what you see to your right would be a servicer, a spacecraft that we will design, build, own, and operate. And what you see to your left would be our client. So a satellite that is already in orbit, and needs services. We do that because there is a new economy in space, and there are many assets in space that are worth servicing. There's a number I like to share. From the first satellite that been sent to orbit, Sputnik, November 57, to 2020, there are about 2,500 satellites that have been sent to space until 2020. In 2021 and 2022, there are probably 4,000 satellites who've been sent to space. So all that just completely changed the whole story. So there is an economy up there, and there is a need of servicing, and that's what we do. We specialize in orbit servicing. Okay, I'll start by sharing a couple of 3 videos, and which is the recent launch. The videos are from May 1st, so 2 months ago. So a few minutes, and then I'll speak again.
3, 2, 1. Engines full power. And liftoff of Viasat 3. Go Viasat, go Falcon Heavy.
So this is our first launch.
Vehicle is pitching downrange. M1D chamber pressure is nominal.
Super comfortable when this left, and then 4 minutes later, I was feeling
of our second stage and successful deployment of the Viasat 3 payload, and we're now coming up on the deployment of the Gravity Space 1 payload. Gravity Space 1 is a 16U CubeSat and the first commercial CubeSat in geosynchronous orbit. It will be used for Internet of Things, a rendezvous and docking experiments, and orbital slot reservations. And that deployment is coming up here in just about 15 seconds or so.
There it is. So probably what you saw is a bit of foreign language to you. I'll explain that in a minute, but this is something that we're super proud of because we launched the first ever nano satellite into geo orbit, and it's working, it's functioning for the last 2 months, and we have customers using that satellite. So it's quite a big success for us, and we're proud of it. But before that, I want to share a bit the story of the company. The company started in 2007 out of Columbia University. There's an INSEAD professor that became a major professor, Miklos, his name, Miklos Sarbury.
Oh, cool.
Yeah, and he became a major professor at Columbia. His son had an idea and won a NASA competition, and the idea was to use AI, to use autonomous navigation to make in-orbit servicing smooth. So make satellite navigate autonomously like autonomous car would navigate autonomously on Earth. And that will foster space rendezvous and then will foster a big economy. That professor called a bunch of INSEAD students. I was one of them. We were friends, and we joined forces and invested in that company. And then we took it to the journey that you see. We did a lot of collaboration with Stanford, where the technology was matured a bit, and then we won an ESA competition. For those of you who know, European Space Agency. And then we definitely settled the company in Toulouse, France, which is the capital of space, and we start some collaboration happening with CNES and other space operators in Europe. Okay, what we do is we have 2 offerings for in-orbit servicing. A first-generation servicer, we call it Orbit Guard. That's the one that's being launched, the little CubeSat that you see here in the screen. That was launched back in May, actually April 30th exactly, US time, and May 1st, European time. We're also working on a second-generation servicer, a much bigger one that will be able to do docking. So the first level of in-orbit servicing is you service your customers without touching your customer, which is difficult, but still doable. You need to rendezvous, find your customer. The second level is actually you dock to your customer. And that's what we call docking-based services. We're not ready. We'll be ready in 2025, 2026. It's our big story, and there is a video that... Oh.
Voyager à partir de
That's not it. I'm sorry. Okay, I think the link is to some...
Où voulez-vous aller?
All right, there it is. Okay. All right. So, this is
Could be worse.
could be worse. It's what me and my sons go on YouTube for. Can I find the presentation again? Okay,
You
there it
just
is.
click on the other tab, yeah.
Okay. Okay. All right. So just to really explain again, we do two type of servicer. One that for those of you who know space, it's a 16U CubeSat. It does rendezvous, so it gets closer to a satellite, and it can sell a certain type of services without actually docking to a satellite. So we get closer to our customers, but we don't dock to our customers. And the type of services we sell there are surveillance, inspections, and things around that. It's called SSA, Space Situational Awareness, but we don't dock. Then we're building something much bigger that actually dock. And once you dock to a satellite and can grab a satellite, then you can sell all kind of services from moving the satellite, extending the life of satellite, maintaining the satellite, and then ultimately refueling the satellite or repairing the satellite. Okay, but I just chose to show you a lot of videos and a lot of pictures, and because I'm not sure how people are familiar with space. So this is the satellite that we're building, that we launched, and we're building two more. It's what they call 16U. It's roughly 30 kilos. It lives 5 years in space, and it has electrical propulsion. Not yours, but maybe soon in the future. We're discussing that.
I recommend.
Yeah, I know we're okay. We'll talk later, but the discussions going on there. This is our core technology. What makes us really different from, like, a lot of people make satellites, a lot of people operate satellites. What we do differently is, and we have patent on that, and think that is what we call a rendezvous technology. It's autonomous vision-based rendezvous technology. The little camera that you see here has a lot of software on it. If some of you are familiar with the way autonomous driving cars function, they use some of this technology. It's AI-powered camera with a lot of embarked software that can recognize an object, recognize the movement of an object, and decide autonomously what to do, how to navigate, get closer, get farther, fire a thruster, fire another thruster, stop this one, turn around, go away, abort missions. All that is done automatically using a very simple camera, which is super unique in space, because otherwise you would need so many sensors, and so many sensors need so much energy, needs a lot of weight, and means complexity in space. Camera is the most simple thing that you can have in space to navigate, if you can solve the problem of putting a lot of intelligence in that camera. What else do we have? Yeah, more pictures. I'm assuming some of you are not familiar. So this is the big satellite that was launched via Sat3, as you heard. Our satellite is on the ISPA ring here. This is the top of the rocket. You know, we manufacture this small little thing here, 16U CubeSat. You see it a bit more here, mounted on the body of the rocket. You see me, you know, here super proud of that little camera that we're sending up there, that we're testing our rendezvous technology. Manos, my co-founder, myself on the satellite getting built. And then you see the NORAD 56,372, which is the number NORAD gave to our satellite. That is today somewhere over Colombia, rising to GEO. This is how we operate a satellite. You know, we have a bunch of software. Some of it we built ourselves, and then we install that, and then we're connected to ground stations around the world who are communicating with the satellite. And right now we are completing the few hundred kilometers that we need to go to GEO. We have 700 kilometers remaining. We should be there August 29th. Actually, before that, hope. But you know, right now, this is how we operate the satellite. We put a little picture. This is public information. I didn't put the name of the customer, but we have some of the major, probably the biggest satellite operator in the world as one of our customers. So we already pre-sold the capacity of our satellites. And the fact that we have something real that is in space and operated have completely changed the market vision towards us. So right now we're selling the capacity of the satellite in 2.5 years from now. People are taking risks with us. The satellite can die tomorrow. This is space. The first time we do such a thing, such a small satellite on such a big and far orbit, but people believe in it and then buying capacity of a satellite in 2 years. If the satellite lives for 5 years, I'll be a rich man. I'll pay for the drinks next time we all. But for now, I will not. Okay. Thank you. But I don't have more than that. I'd rather, answer any questions later.
Thank you so much, Adel.
No.
So with this, why don't we move to Lucy, and Lucy will talk us about a totally different aspect. And why don't I let you, Lucy, introduce what you do and what your company does.
Thank you so much. Let me see if I can share my screen. Blah, blah. And okay. Slideshow. So can everybody see the scary American eagle?
Yes.
Yep. Okay. Then we're all good. So Adel, thanks very much. It's a really nice introduction what you guys do. Because of course Spottit sits in the part of the space sector that's called downstream applications. That's our space sector jargon. Adel sits in upstream. So anything where people are building hardware to go up into space, or the launchers that are taking hardware up into space, that's called upstream. And I get really excited about the data that streams down from space and building services from that. So maybe I give you a little bit of a background. First thing I should say is I'm not an INSEAD alumni, but my two fellow co-founders, Paolo Senis and Marcello Di Plano, are. So guys, maybe you just introduce yourselves quickly. Paolo, go for it.
Yeah, ciao a tutti. Paolo Senes, INSEAD MBA 2001D.
There we go. And Marcello.
This is Marcello, MBA July 2004, based in Warsaw now.
There we go. So that's the skill of an MBA. You can delegate the actual presentation pass to your fellow founder and CEO. So when we talk about satellites up in space and space data, there are kind of three main groups. You've got satellite navigation, satellites that, as they say, they're doing the GPS and the location data, satellite communication, and then Earth observation. And so Spottit works with Earth observation data. This is all kinds of things like imagery. So all the high resolution imagery that sadly we've got used to seeing of Ukraine, and also other kinds of data from other kinds of different sensors. So a bit like I did, I give you a little bit of a story as Spottit's journey. Neither myself, Paolo, or Marcello have any background in the space sector or Earth observation, but we were chatting one day about Marcello's work in renewables, and Marcello was commenting that, we do these multi-billion-dollar onshore wind farms, but you wouldn't believe the Mickey Mouse data that we use to find sites with suitable geography. And we scratched our heads and said, yeah, but aren't there all these commercial satellites, and we can do computer vision, we can analyze this data. So we went and looked into it, and ultimately back in 2014, we took this idea to the European Space Agency, and we were awarding grant funding to essentially bring Spottit to life. So Spottit is a spin out from that. And we started predominantly with renewable energy services and site location, but now we help owners of critical infrastructure, be it gas, water, power, utilities, also road and rail in the future, and also landowners as well, provide critical infrastructure monitoring using satellites. So what's the big vision? I mean, cleverer people than me have stated that, satellite data and analytics is one of the key enabling technologies for our transition to net zero, monitoring what we're doing and where we are and where we're going. So basically, we couldn't understand why more companies weren't using this data and why the services weren't cheaper. Traditionally, this has been a sector where the project-based consulting has been has been alive and well for the last 12 years. You find an expert, they develop an algorithm for you, and it works in one part of the world and does the thing that you want it to do. Spottit's vision was much, much broader than that. Everybody, all businesses, should be able to have intuitive and affordable access to geospatial analytics and metrics to achieve their business and sustainability goal. So we're all about simplifying access to satellite-derived geospatial metrics, basically to help organizations increase the value and the performance of their assets. And we do that with our in-house algorithms and fully automated work processes, which is really exciting. We have lots of fun doing it. Just briefly, in terms of the company, we're now 15 people based in the UK and Poland. But as you'll see from the chart, we do projects all over the world. That is the beauty of satellite data. I can be nosy anywhere in the world, and a service that I develop and that works in France will work in Australia, will work in Canada, will work in South America. Slightly more complex than that, but in principle, you have a global and seamless data set. So as I mentioned before, we work with a lot of power network operators, increasingly with oil and gas infrastructure owners, renewable and other infrastructure managers with sort of land and asset owners. So what are the problems that we're solving? What's the use cases that is interesting and relevant for them? And why do they care? What are the trends in the industry that are pushing them towards needing these kind of solutions? Because traditionally, these companies are monitoring their assets. They are walking, literally, they are walking around power lines and things like that. Every few years, some might be flying aeroplanes and eyeballing out of the window. They might be taking video from an aeroplane. They might be conducting LiDAR surveys from planes and helicopters. And some are not doing anything at all. So for example, the gas pipe that goes into your house, no one will ever have inspected that pipe or had a look at it all unless you smell gas and you ring them. And it's probably been in the ground for about 30, 40 years. So asset owners are being increasingly driven to using geospatial data or seeking to use geospatial data because of the age of their assets. They're getting older. Climate change is really, really impacting A, the performance of their assets, and B, they need to understand how to invest to mitigate these issues and how to invest in future extensions of our infrastructure. And, as a public and as society and governments, we have increasing expectations on the safety and reliability of our critical infrastructures. So when I was a young girl living in a village in the UK, it wasn't horribly common, but it wasn't uncommon that we had the odd power cut 2 or 3 times a year, and that was absolutely acceptable and absolutely normal. I mean, nowadays you cannot do anything if you lose power. The Wi-Fi goes down, we can't work from home, we can't move money, the economy really grinds to a halt. So we really expect our infrastructure to perform. And there's something like $2 billion a year of avoidable losses because we don't know and we don't look at what's going on in and around our networks. And also there's increasing legislation driving critical asset owners to do more monitoring. And that can be direct, as in, for example, the new methane monitoring regulation that's under discussion at the EU. And that can be indirect in terms of regulators increasing penalties for poor performance and things like that. So we talk with a lot of customers who want to increase the frequency with which they monitor their assets. They have a problem of scale. They have hundreds of thousands of kilometers of assets, or many assets spread over a large area, or even assets in different countries that they want to monitor in a standard way. And it's just too expensive for them to do more, fly more aeroplanes, have more helicopter crew, have more crews on the ground walking around. And also, they're not there yet, but from the point of view of carbon footprint, helicopters and cars and aeroplanes are not a great deal for that. They're going to add to your footprint. Satellites are a much more CO2 footprint friendly solution to monitoring there. I think I've touched on some of these points too, but let's go through. So there are lots of different types of sensors up in space, and with that we can do different types of analytics, and we can give our clients different insights, and you'll get a better flavor for that on the next slide. So we can track many of the causes and many of the risks in and around different assets. Satellites provide remotely sensed data. So you're not investing in hardware in and around your assets. You're not investing in physical surveys. So it's very cost efficient and very easy to coordinate from an operational point of view. Companies like us, we can generate all kinds of different metrics and insights from the analytics we deliver, and those can be integrated into our clients' existing geographic information systems, asset management software, work order management software, etc. And we're traditionally much quicker than existing LiDAR or other monitoring solutions. We can gather the data quickly and we can analyze it quite quickly. To give you an example, we are doing a habitat classification for the whole of Warwickshire County Council. It's 2,500 square kilometres. We gathered the data for that in 3 days, and we're busy now processing it. And that would have taken them 5 years with a team of ecologists to do. So there's a big difference as well in delivery times. Here are the kind of use cases that we focus on, and it's worth saying that there are other analytics providers that focus on different sectors. So you will see things in agriculture, commodities, insurance. There is a growing number of areas where satellites and satellite-derived services are making an increasing impact. And I think you're just going to see that happening more and more. So I'll just run through very quickly. So things like vegetation monitoring, third-party work and change detection, and biodiversity monitoring, those are traditionally done with what we call optical sensors. So those are the pretty colorful pictures that they're used to seeing. And we have machine learning based algorithms that will classify different things, will extract features and do various different clever analytics on that. If you're looking at different types of sensors, so there's a type of sensor called a SAR sensor. They are beautiful because you can take a picture in the dark and they can see through clouds as well. But with that kind of data, you can do something called land and asset motion. So you can use satellite imagery to monitor the movement of land and assets very, very accurately, plus or minus a millimeter. And this is much more cost effective than sort of some physical survey techniques. And it's increasingly being used across infrastructure and also dams and things like that. It's also excellent for near real-time flood monitoring. So we have the capability for our clients to come onto our system, the rain is falling, the flood is building up, to task a satellite in space through one of our imagery providers. The image will be taken, will be beamed down to Earth, will be delivered to us, and a couple of hours after we've got the image, we can deliver for our clients a 40-kilometer by 40-kilometer flood footprint analysis. So very, very speedy as well. Other types of satellite data are, let's say, climate and weather data. So there are satellites in a very high orbit that for many, many years have been collecting data every hour on hours of sunshine, rainfall, you name it, temperature, a whole range of different things. And we often use that data to help our infrastructure owners understand which assets may have had a harder asset life in the last 40 years than others, and also what the trend is. So where do they see climate change and how can they map that to their assets? We've done quite a bit of work with a number of UK utility network operators there. And then another exciting area is the concept of greenhouse gas monitoring. So these are specialist sensors in space that are designed to monitor the concentration of a specific element or a range of different elements. So you will have heard about methane monitoring, and those GHGSat have a constellation of commercial satellites. There are some open source data as well, and there are some new constellations coming on board as well. So that's a brief run through of some of the different services that we focus on from the point of view of infrastructure owners. I wanted to talk a little bit about different types of providers, because I think it's quite confusing for companies when they start out their journey and they're looking to do something with satellites. So once Adel Sensors takes data and it gets beamed down to Earth, you're going to source that from your data provider. So, and those are people typically in the top left-hand corner of that chart. You can either work directly, so with the Airbuses, the Planets, and the Maxars of the world. Increasingly, there are also kind of satellite data marketplaces. So Skywatch is an example of that, where they agglomerate satellite data from lots of different providers. So you can go to one shop, as it were, and buy lots of different types of data. Then on the right-hand side, you've got people that are more service providers. So generally, it's not our clients that go directly to the data providers. It's complicated for them to know what data to use, what to buy, what format to get it in. They would go to a service provider like Spottit, and there are other names on there who are also, active in terms of, providing analytics and services for infrastructure clients. So our clients want to buy the service. They don't want to buy the satellite data and have to do the analytics in-house. And that's because we're just A, better at what we do, and B, we've been doing it for much more time. So they need these insights now. They don't have the 3 or 4 years development time that Spottit has had in developing these kind of services. Different analytics providers have a different focus. They have a different theme. So, Spottit, our obsession is really automation at scale and the training and retraining of our algorithms. We believe that gives ultimate massive value for our clients. The more clients we have, the more data we have, the more we can invest in automation and improve our algorithms, and round the circle goes. And we find that that's, really being noticed by our client. Some providers focus only on one type of satellite sensor, and others like Spottit like to think that we bring all that space has to offer. Also, another differentiator is some analytics provider provide tailored solution to a specific vertical. So they would provide a satellite-based vegetation management platform for power network operators. That's not Spottit's view of the future world. We think that our clients have got enough platforms doing all kinds of different things, and what they lack is the geospatial data and insights to be plugged in to those platforms for them to do analytics on top of our analytics. So it really just depends what your take is on the world. So, analytics providers, we come in different shapes and sizes. We have different focuses, generally focus on different sectors as well. As you hear, my passion is the infrastructure sector. I've also worked with the European Association of Remote Sensing Companies. They have a network of what they call EO evangelists, and I'm their EO evangelist for infrastructure, which is possibly one of the reasons why I got invited to chatter a bit today. Is it difficult to work with satellite data? Well, not if you're using a service provider. All you basically need to show is you need to know where your assets are. Now that sounds rather obvious and potentially stupid, but sometimes that can be a little bit of a challenge for some of our clients. So for example, we've worked with, I shall name no names, a gas network operator saying, you know, we need to know if there's any building that is within 5 meters of our underground gas pipeline. So they give us the location of the assets, we run the analytics, and it's clear from the data analysis that the pipeline is, you know, 10 meters to the west of where they've said it is. So, you know, there are some interesting challenges there that our clients need to have their geospatial data, you know, in fairly good shape to be able to get the most of this. But then your analytics provider will manage that the, you know, the data is provided, the analytics are delivered, and everybody has what they need. So it can be very, very easy. You got to work with the right people. I think that's the important thing to say on that one. But it's extremely exciting, extremely dynamic sector. It's very interesting to see in the infrastructure world that there are clients we spoke to 3 years ago who said, don't worry, Lucy, we've got everything sorted out. We're going to do everything with drones. And they're back now, you know, paying us to do analytics because it's impossible to do frequent revisits of large numbers of assets. And in fact, the infrastructure sector is starting to understand that it's not about finding one monitoring solution that does everything. It's about understanding how to operate a blend, a hybrid of different monitoring solutions to get the most value from the money that you invest in monitoring. So I think I'm also going to say something a little bit off topic. Next week, I am part of a 4-person swimming team that's going to try and swim across the English Channel. It's 33 kilometers as the crow flies, and we're doing it in aid of the charity Access Sport, which works with underserved young people in their local communities to access more sport. So if anybody's interested, you can find me on LinkedIn and you can find the link to donate there. So now I will shut up and pass on to somebody else. Thank you so much.
Thank you so much, Lucy. So somebody already sent a question to Lucy. Feel free to post your questions and we'll read them out loud after the last presentation, which I will do. So let me see if I'm able to share my screen. Share, and let me see if I can put this into presentation mode. Okay, so I hope you can all see my screen, and I'm not sure which version you see, but
we're not seeing the you're sharing the presentation, but not the
it's not in presentation mode.
Not the presentation mode.
How about now?
Yes, now it's good.
Perfect. So you have heard from 2 different aspects of the satellite industry, and I have to say my slides will be less colorful, so I apologize for that. It's a bit more technical, and there is a reason to it. Satellites are very tangible. They look really cool, and some of the use cases we heard from Lucy are also quite real. It's about planet, it's about observation. What we do at Tarides, we actually develop the backbone of technologies serving those kind of use cases. When we talk about different people using satellites for different things, well, that requires software. And in order to actually serve those different use cases, it requires software that is changing. So traditionally, satellites were typically owned by one owner. They were launched and they were not touched after. So depending on the type of the satellite, the lifetime can be 5 years or 15 years, but historically they were launched, they were operated, they were not touched. Very rigid structure, very costly, time consuming. It's very difficult to access for new solutions in a user-friendly way, which is really the foundation of NewSpace. I'm not going to tell you too much about NewSpace, but still from a technology perspective, it may be interesting to understand that what NewSpace means, it means that satellites are now used between different users. So there could be multiple companies running their software on the same satellite. It means that the software platform has to be flexible enough to serve that. I mean, the satellite may be doing one thing for a certain period of time and something different at a different time. We need satellites who can serve that. We need software who can serve that. Security has to be very, very strong, because if you put up new software, well, you have to be very careful that that software does not interfere with the other company's software, or heaven forbid, with the flight software of the satellite itself. So it has to be super strong. And it has to be also very, very easy to use. I mean, if it's something you need a PhD to do this, it's not going to take you so far. And that's the problem Tarides is addressing to solve. And we are solving it by focusing on the operating system layer. So some of you are engineers, I apologize if I'm boring you, but some of you are not. So I'm trying to explain what that means. If you think about the satellite, you have the hardware, and that's what Infinite Orbits does. And they do way more than that, but what we have seen was primarily the hardware. Then you have the operating system, which is basically the layer between the hardware and the user software, because Lucy's company is focusing on the user software and actually using the satellite. Between the two, you have the operating system, which provides a home for those different applications. And then we have the user, which is using the data, which user could be either in the satellite, if it's edge computing, sometimes computation happens in the satellite, or it could be on the ground. Now, why would anybody want to solve that? I mean, there are solutions there today. I mean, we heard about different applications already. Well, the solutions are not necessarily very optimal. So some companies are saying, well, there is no platform today, so they develop everything end to end. So I'm talking to many satellite companies, they say, well, we have developed the operating system, we have developed the hardware, we have developed everything around it. Is that doable? It totally is. Is it efficient? No, it's not. I mean, it requires a lot of resources. There's a complete lack of standardization. It's not very efficient. Also, other companies are using existing technology. They're using technology that provides containers. Containers are things where one can put software so it runs securely. But these are solutions that were not designed for resource-constrained applications like a satellite. I mean, we do not have super powerful computers and satellites. Why? Because they require a lot of energy. We don't have so much energy. That's one of the reasons. So what we are proposing here, we are proposing a new technology which actually solves all of those challenges and solves this in a standardized way. It provides multi-tenancy, so one can put up very easily software in containers, and that container is completely contained. There is no interference with any other software. It's highly flexible. You can update software. You can upload software. This is for everybody, most people who are not familiar with satellites, this is obvious. I mean, you update your software, right? When we were presenting our concept to the European Space Agency, they said, well, this is a fundamentally new concept from an engineering perspective. It's not really done too often, because sending data to space, if there's a bug there, if it doesn't arrive correctly, there's nobody to kind of go up there to fix it. So it has to be super robust, and it has to be a very, very small file, because sending data over such big distance, it's not an easy venture. It has to be highly secure, and obviously we provide that in addition to an ease of use. Now, people ask me very often, is this really safe? How does it work? And I apologize for those who are not engineers. Again, it's not necessarily so exciting, but they are very different. There are different technologies when it comes to security. And when we talk about software development, there is a concept called secure by design. So there are certain programming languages that are very easy to attack. And some classic languages like C or others, they are actually unsecure by design. So one of the things Tarides does, we use a language which is memory safe. So by design, by people doing nothing else, 70 to 90% of all cyber attacks are made impossible. Why is that important? Everybody needs cybersecurity. It's very different if you need many layers of protection, or if you already have a default set of protection without any additional efforts. So that's what Tarides technology does. And really the question is, does it really work? What's the impact? So let's assume we use SpaceOS, which is the name of this technology, and we compare it to the classic solution, which we have validated with Thales Alenia Space. So Thales told us, here's an Earth observation software, which we use today. We use a technology called Docker and Kubernetes. It's a program written in C. Can you please demonstrate, does this work in your environment? How does it work? Is it better? What are the benefits? We took that software, we completely replicated the functionality. And what we were able to demonstrate was that the actual software code, which is very important because you have limited storage space, was 20 times smaller than the code used by Thales. And it required significantly less memory. It was significantly faster as well. On top of it, it was significantly more secure. So from a cybersecurity perspective, this is a very, very robust environment. So you may find this interesting. People say, okay, so how can you replicate something? How can it be 20 times smaller? Because we use a fundamentally different technology, a technology that's called unikernels. Everybody knows operating systems, Windows, Mac OS, Linux. They are all very similar. They're very powerful platforms. You can run pretty much any application on it. Good, right? Well, if you think about it, it's powerful, but it's not very efficient. Why? Because if you use any software, you typically use only 1%, 5%, maybe 10% of the operating system. The remaining 90% you don't need for that software. Other software pieces needed. Your specific software doesn't. So what we said, well, that's a fundamentally flawed approach. We are using operating systems that is not used 90% of the time. What if we took a different vision? What if we said, let's look at the application itself and let's build an operating system that's custom for the application. If we know that the application does not need a printer driver, there will not be a printer driver. If the application does not need a display driver, there will not be a display driver. So we include only the strictly required components. What's the benefit? It's significantly smaller, which makes it more efficient, but also smaller means a much more small attack surface. So cyber attackers, in addition to memory safe, have way less to attack. So that's what unikernel technology is. And for example, the US military is using this kind of technology to protect some of their assets because they believe that unikernel as an operating system is fundamentally more secure than those generalist platforms. And I'm not even talking about the efficiency part. I mean, if you need to send a file that's 20 times smaller than another file, obviously there's 20 times less of risk of a cyber attack. Now, what does that mean for space applications? I mean, yes, it's an operating system, but what can you do with such an operating system? I mean, first of all, you can use it for all kinds of NewSpace satellites. I mean, if there are satellites with multiple users, but you can also build something which you are hearing very first today. It will be officially launched at the upcoming NewSpace conference at Station F tomorrow, which is a platform, GASAAS, which stands for Satellite as a Service. And Tarides is developing it jointly with OHB, which is one of the largest satellite manufacturers in Europe. What the platform does, it makes satellites accessible to the average business user. So we heard about use cases Lucy is working on. Lucy could come to us and say, I need visual data of these kind of assets without knowing anything about the satellite, without knowing anything behind it. This platform, which we provide, will identify which satellite has spare capacity, which satellite can provide the data to Lucy so that Lucy gets the data. So the platform connects business users with satellites without them needing to know each other. So it makes it very accessible for business users. Now, satellite owners, they very often, I was just talking with Adel, and he said, well, his satellite may have some spare capacity. It's not being used fully 24 hours of the day. So if the platform knows that certain satellite has some spare capacity, it can match the user with the satellite capacity to provide that full use case of the satellites. How will this work? It will work by using SpaceOS in the satellite to provide complete isolation of the software. It will be using SpaceOS in the cloud platform so that those two can communicate with each other. And OHB will provide all the infrastructure around it to make sure that it's a complete solution. And sometimes people ask us, okay, so can this kind of technology work for other industry segments? It absolutely can. I don't want to talk too much about that. On our roadmap, we will launch this technology for other critical edge applications, automotive, et cetera, et cetera. But today we talk about space. So I leave it at that. And that was really the end of it. So hopefully it was not too boring. And let's open up the chat. I'm stopping the sharing here and let's start to look at the questions. So people were commenting to Lucy, amazing, congratulations. So Lucy, first question to you. So can you satellite data spot defective gas points that can cause explosions?
So I replied to Clive here, but for everybody, the answer is in parallel, yes and no. So it depends on the size of the leak that you want to detect. So the constellations that we have available, flying up in space, providing data, they can reliably detect leaks that are 60 kilograms an hour or more, and they are being used commercially for gas production, gas storage, and sort of manufacturing sites. Now, where I would like to go is that we can use satellites, because of course, satellites are great for scale, to monitor our gas distribution and transmission networks. Now, there, certainly in Europe, a transmission or distribution network operator would never aim to have a gas leak of 60 kilograms an hour. That's absolutely huge, and it would be pretty catastrophic, and they would see it on their pressure meters. So they would be looking to be able to detect lower gas rates, the smaller leaks. And in terms of sensors that detect that, we're not there yet, but there are new sensors and new constellations in the planning that will bring that threshold lower. I think the other thing I want to say on that one is a leak is the end of the road, right? That's a failure of your installation and your monitoring systems. So there's a lot that we can do before you get to that point in terms of monitoring land motion, the conditions that you're, which parts of your network have been flooded more often, so there'll be more corrosion, encroachments, people digging and doing stupid things in and around your network. So for direct monitoring at low levels, we need the technology to deliver. Monitoring indirect, the things that matter on the journey to a leak, yes, we're there.
Thank you, Lucy. Anybody, any other questions?
I do, for Lucy, if you can.
Go ahead.
It's very interesting what you do. And I was actually wondering, I saw your graph before, and it seems very different. What you actually do as Spottit seems very on a different axis with respect to Maxar, that I guess is there because of the acquisition of Digital Globe, I guess.
They are data providers. They own the satellites.
And they are the most probably the initiator of that many years ago. And the other thing is Planet. In my head, knowing the business a bit, more than a bit, to me, they're placed pretty much in the same spot as you are. But I was actually, so that's why, I wonder in what Spottit is very different from what they do, because it seems to me that they do pretty much.
Okay, so let's look at that. So Maxar and Planet 2 are data providers. So I have bought imagery from Planet just as I've bought imagery from Maxar. As an analytics provider, we like to stay a little bit free and liberated on the data sources that we use, because there are definitely some that are better for certain applications than others. Now, it is true that data providers like Planet sometimes play both games. They do provide some basic value added services to their clients. They always have done, right? But history tells us, and I mean 12 years of history, I'm not talking about 2 years. The commercial high resolution satellites have been floating around for the last 12 years. So history tells us that data providers cannot provide tailored services to specific sectors. It's not their core business. There are many improvements that they can do in terms of automation of satellite tasking, speed of data delivery, etc., etc. But some do go into the analytics realm, but there is a noted difference. And for example, Airbus will push all the analytics projects towards us because it's not their core business. They predominantly offer some basic analytics to help get potential clients onto the ladder, or to help a client envisage what they could do if they went down that.
Airbus is by definition, it's not a core product of them. It's just they're more upstream in the value chain. But that, in fact, I was referring to Planet Lab. And
well, Planet is also a data provider. So their core product is that you buy access to imagery from them. They have a different business model in terms of it's more streaming of data via their platform. But ultimately, Planet asked me I pay per kilometer square of data that I stream. If I want to do some analytics, I can pay a little bit more on top, but I can't just do analytics with them. I buy their data and I do analytics only on their data, right? So great if Planet is the ideal source of data for your particular type of analytics. Have I kind of explained a bit the difference there?
No, I understand that. I guess we're very clear that the value is in integrated data. It's not getting the image. It's just how good the algorithms are in order to reply to specific clients in oil and gas, or just forestry and maritime. So
I think my observation on that is the winner in this sector is not going to be the one with the best algorithm. It's going to be the one that seamlessly delivers the service and the answer that the clients need. My sector is great at talking technology. We are not very good at talking services and how we meet the needs of our clients, but I like to think we're trying to do a better job of that.
Thanks.
We have a next question from Clive.
Yes, I'd just like to be clear about this satellite thing. But first of all, it's a fascinating topic. All right, I would never have believed it. I will actually put my face up so that you can see me. All right, there we are.
Perfect. Hi, Clive. Nice to meet you.
Now, what I'd like to understand, I can understand all this data streaming down from satellites, all right, all over the world. I'd like to understand though about data streaming from the ground towards the satellites, and that's where I wasn't clear. I think the very first presentation, when we're talking about doing some sort of servicing of satellites. So can you explain that to me? I'm not. It's a little bit unclear to me.
Okay. I assume that's for me, right?
Yes.
So what's servicing a satellite? The best example, I used to run a cement plant, in my life. Cement plant is a big thing that has 200 employees. It's worth 300 million euros. And usually my board would give me 5 to 8% of the capex value, so 15, 20 million, and say, spend that on maintaining the plant. Okay, what does maintaining the plant mean? In my case, means surveillance. There are a lot of thieves. People will come, will destroy things, will material things like that. That means fixing what is broke. That means moving things from one place to another. A big geo satellite that is used to do communication. I'll take a company, Intelsat, an American company, or Eutelsat here in France, or Arabsat in Saudi Arabia. They have a lot of big satellites worth 300 million euros each. They put them in space, they live 15 years, and they use them to communicate. If you are on a boat in the middle of the Pacific and you want to have internet, that communication will go through a big geo satellite that is worth 15 million. That lives for 15 years and worth $300 million. Sometimes those satellites are attacked. Okay. And this is a reality, like another harmful satellite will come next to you and will try to prevent you from working. And the owner of the satellite, Intelsat or Arabsat or Eutelsat, they don't know. So you need to guard your assets. You have something that is worth $300 million that is roaming in space, 30,000 kilometers from here. And literally, you can communicate with it. You send data, you get back data, but you don't know who's next to it. It's like a very simple thing. You don't know who is next to it. And somebody else, and this happened, it's documented, can come 2 meters from your satellite and try to create interferences, try to destroy it. And you simply don't know who's there. So there's a very basic service of guarding your assets. You put a small satellite next to it, it roams around it, it circulates around it, it's like a few hundred meters, 300 kilometers around it, and it has cameras, and it's seeing what's happening. It's like you'd be sending...
But do you send up those satellites then? Do you send up the satellite, which is going to then circle the 300 million satellites?
Yes.
So
yes, and that service is called surveillance. So I'm surveilling an asset, and that's a very basic level of servicing. Sometimes simply your client, they tell you, and this is also a very concrete case. There's a big satellite that's being sent 3 years ago, and it was supposed to have 100% of capacity in terms of throughput and communication, and it has only 75% of that capacity. It was supposed to have 100 megabytes, and it has 75 megabytes, and they literally don't know why. Because it's exactly 75%, they assumed that one of the solar panels didn't open, and it was broke. And so they only have 75% of the power and 75% of the communication capabilities, but they're not sure. So they need someone to get closer and take a picture, because that's used against insurance and things like that. It's called inspection. People want their assets to be inspected. Like in my cement plant, I want it to be inspected. I paid people on drones, I paid people with cameras, they go on ropes, and they just see what's happening on the top of the tower.
But for instance, can you then repair that solar panel?
Yes. Right now, no. But the assumption is in the future, we'll be able to repair satellites.
2025. That's the idea. 2025, you'll be able to have a docking satellite that will be able then to do some sort of repairs.
Yes, correct. The first thing when you dock is you actually move. You take over the moving of the satellite. So you tow it in a way. So it's supposed to be over Italy, and then it's drifting, and it's over Greece. Then, well, you dock to it, and then you bring it back, and you maintain it over Italy, because that's what you needed. That's the very basic service that you sell when you dock, called life extension or station keeping in our jargon. Later, maybe in 2030, you'll be able, with a robotic arm, to go grab something that is broke and then put something else. And this is called repairs. At some point, you'll be able to put some fuel in it. But right now, like the first thing that we are aiming when we dock is to take over the navigation of the satellite.
Okay, many thanks. I just want to make one point. I'm very struck by the discussions re space debris. I mean, as a sort of a very down and earth human being and all that. But I say to myself, I mean, one of you saying your satellite only lasts 5 years. I'm wondering now if they can build in the idea that after whatever the length of use of this satellite, that after that it should be able to, let me put it, self-destruct, but in a safe way. All right, the idea goes into lower orbit and gets all burned up or something. But I'd be very curious if we were to have a discussion. We can't do it now, right? But if there's some sort of presentation about space debris, because I would have thought that is a major topic. All right, absolutely key.
Right. I can say if you I see Florian. Maybe I think you can answer better that.
Hello everyone.
Sorry.
You will hear me now. My name is Florian. I work for the European Space Agency. I'm a VFC 20 at INSEAD. Indeed, tomorrow we have a session of space sustainability. It's at the INSEAD NewSpace for those who will be in Station F. It's a big topic. We just signed. It's hard to regulate. Some of you that are doing space law or law know very well that it's a place when it's very hard to enforce law in outer space because it's all like national international treaties. We have charters that are in Europe. For example, we launched 2 weeks ago a zero debris charter in Europe to help the industry commit to not having debris. Then we have companies, including Infinite Orbit, that are working on docking system to deorbit. So it's always like you need to send a spacecraft in orbit, deorbit another piece. So you have to have something that is very efficient. Otherwise, you're just maintaining the system. So we are working on solution. It's a sustainability issue for everyone because just out of even if you take out the environmentally friendly kind of notions, it's just like we won't be able to have any business in space in 50 years if we don't take care of that now.
Okay.
But just to assure you, Clyde, there are already enough laws. Now, of course, not everybody's respecting, everybody's doing what they want because access to space, no disrespect, but Equatorial Guinea has the same access to space as China. They have the same rights in space, and everybody can do whatever they want in space. Our latest satellite is built in Denmark, owned by a company in the US, launched from the US, and registered in Papua New Guinea. So what law should I obey to is very hard to me to answer this question. But to assure you, all the satellites are supposedly built with the idea of managing their end of life. If you are in a geo orbit, it's quite respected. So when your life is over, you move above geo to something called the graveyard. And so you roam there. There's only like 500 satellites, so it's not a big thing. So you roam there and you're not a danger for nobody. But yeah, you're still a piece of debris in a way because you're the dead satellite, but very in low Earth orbit is much more complex. You're supposed to direct yourself when your life is over. You're supposed to direct yourself to self-destruct with the right angle. You re-enter the Earth and you self-destruct. Now, not everybody is able to do that. Not everybody is actually doing that, and there is a lot of debris up there. What Florian mentioned, something that we're working on is a service in orbit, is actually to clean the space. It's called active debris removal, ADR. You want my opinion? It's bullshit because it's not going to fundamentally change anything. Some people are happy doing it. Maybe we'll do a mission or two, but you need $100 million to go clean one piece of debris of a few hundred kilometers. And in reality, you have 80,000 pieces of debris, and some of them are as big as my phone and as destructive as other pieces of debris who are like much bigger. So as a humanity, we need to do a couple of these missions, but this is not going to change the situation. What will change the situation is our ability as human beings to sit on the same table and to have some very simple rules. Like last time we were able to do that for space, I was in 69 or 67. And it's like, a couple of pages saying space is used for, belongs to all humanity, is used for peace and blah, blah, blah. Nobody owns it. And we wrote this, and who's respecting this? Nobody. So if I have $100 million, I wouldn't put it in going and taking out a piece of debris from space. I will use it to lobby so a lot of people get to the same table, and at least we get another piece of paper, slightly better than the one of 69. But that's only my opinion. Sorry for my ESA friend. But yes.
Right now, there is an agreement that if you keep sending like tens of hundreds of satellite per year, or like 10% of them are not deorbited, deorbiting one of them is not the solution. Like it's your money is more invested to being sure that the 10% will not there. So that's why we work with the industry, but that you mentioned already, to be sure that the satellite will go down. But to be fair, it's understood. Like when you look at Starlink on OneWeb, they have quite strict rules for the orbiting of their own satellites because they know that they are polluting their own orbits. So they need to take care. They need to take care of that. So Musk, for example, is taking some measures so that their own failings, Starlinks, don't disturb the other ones.
Yeah,
so
it's just like spending so much money and sending something that is 500 kilos to the orbit, something that is 100 kilo, with big chance of not succeeding, sounds a bit misuse of resources for me.
Well, we are still funding those missions. we have one in right now, but you can see that the technology demonstration probably.
And there are a number of startups, right, including yourselves, Miklos, that are looking at that. But I agree with, there is an anomaly, right? The good guys will do what they're supposed to do and follow the rules. It's the bad guys that perhaps won't, and then who do you invoice, right, for the cost of clearing up their debris?
Who invoices?
Okay.
It's a big, difficult subject.
I mean, there are lots of interesting topics. So anybody, any other questions?
I would see more business in prolonging the life of all this geo satellite.
Yeah, that's what we do.
What you know, I mean, really, and it's like buying very expensively Rolls Royce. You send it, you fill the gas tank once, and when it's empty,
yeah, it dies.
It died.
I know.
I mean, Adel is a humble person. I mean, that's what I really like about his technology, that they're really working on that. How can you refuel those satellites? Which is, it's not an easy task, but that's exactly what you're suggesting.
I have a question. Are the current satellites designed with the connections so you can refuel?
Oh, very good question.
So they put it now on the satellite because maybe in 10 years it will be possible to refuel.
Okay. The answer is no. But there are
is there a standard which is
there are some standards. The Americans, something called CONFERS, CONFERS, that are trying to put some standards for servicing satellites. And one of the many initiatives in there, but there are 3 ways you interact with a satellite when you touch a satellite. You can communicate with a satellite when you're closer. You know, like planes, when they get too close, they have a standard communication. They'll get away from here, I go right, you go left. Then there is like physical touching, and then there is like exchanging fluids. Okay, so you know, refueling or things like that. So there are some standards that are being put in place, but I would say the majority of the satellites are still being built without the idea of being serviced one day. OneWeb, for example, they are now, for the future satellites, they're putting a standard piece in their satellite where you can grab the satellite. You know, like when you have a car, yeah, attache caravan, how's that in English? Not sure, you know. It's,
yeah, trailer hitch.
Yeah, trailer hitch, where you can, if something wrong with the car, then that's where you grab the car from, and then you tow it. So some satellites are adding this. Some satellites are also adding a hose, you know, where you can put fuel.
Refuel.
Yeah, where you could put refuel. Some other satellites are working on augmentation. They call it augmentation. So you build a satellite, and then in the satellite that you build, you have a big portion of the satellite that can live 40 years. So the platform can live 40 years. Some of the basic electronic can live 40 years. The propulsion sometimes can live 40 years. But then the payload, the active payload that you would communicate with, it from a commercial point of view, and also from an electronic point of view, can only live 5 or 6 years. Because it's an antenna, it's using Wi-Fi, and then maybe in 7 years, you know, something else, that Wi-Fi. So some satellites are being built so you can plug and change the payload. So you'd send the platform is roaming for like 40 years, but then you did an optical payload to take images, but maybe in 5 years, you don't need to change the whole satellite. You just like go there, rendezvous, dock, take out the old camera and put new camera. So those are the kind of preparation that are built into satellites. But frankly, 90% of the satellites are still being built without this idea of them being serviced one day. It's changing. Some standards are there, but it's and the market is booming so much that everybody now just wants his own satellite. Actually, an INSEAD friend, hopefully he's not there, called me once and said, "Oh, Adel, apparently you're making satellites. Can you make me a satellite?" Like, Jean-Francois, why? Oh, no, I heard, like, 200, 300K, you can have a satellite, take some pictures. And I thought, yeah, but Jean-Francois, why? Then he got and said, Adel, I have a car, I have a boat, I want a goddamn satellite. So people are just like, building and making satellites, and, not necessarily that much into the regulation, as Clive said, and cleaning space, or like making them serviceable. So many countries, for the first time, they can afford to have a satellite, so they're making satellites. So just like market is just like so big into building shit and sending it to space, not necessarily have the time to think how this can be serviceable, how this can be sustainable, how this can be brought back, how this can be cleaned. It's taking some time. ISA's doing few actions there, but frankly, you go to a random country that like had nothing to do with space like 2 years ago, and then we have companies doing propulsion, we're making our own satellite, we're taking pictures, we have ground stations. And, as I said, space belongs to China the same way it belongs to, smallest. Yeah, well, Andorra, So,
Lucy, you want to add?
I have a question for one of the presenters. Adel, there was talk a while ago that, that there would be a shortage of capacity for launching all these satellites that your INSEAD colleagues want to, buy for themselves, right? And we've seen some of the companies that were launch companies not perhaps do so well or make it to the end of the journey, let's say. Do you experience launch capacity issues, or is it a non-issue in your view?
That is the number one issue by far, still today. So apparently there's like 250 new companies in the world, that 270 that got funding and are building some kind of a launch capability around the world. 270. Okay, so it's a lot. Still 60 or 70% of launch capacity from last year was SpaceX. If you talk to SpaceX, they'll tell you, okay, what do you need in 25 or 20? So you need to have a lot of money, you need to buy, and we're in Europe, maybe the audience is not like 100% European, but like in Europe, we're pretty much naked. Tomorrow, is it tomorrow?
Tomorrow night.
Yeah, tomorrow night is the last launch.
The last launch.
Yeah, it was supposed to be June 14th. And it's the last launch of Ariane 5. Vega C blew up like a few months ago. We still don't know why, so it's not flying again. And we used to have a deal with Soyuz that we cannot use anymore. So as the European Commission, European countries, we don't have a launch solution. There's some companies out of Germany that are maybe ahead of others. We will have launch opportunities. But what eats my head every morning is to secure a launch. Like we have a second satellite that will be ready in
where do you put it up? How do you put it up? Yeah,
it was supposed to fly with Russian flight, so we cannot fly with that Russian flight anymore. So it leaves us SpaceX, and SpaceX is telling me 2025, 2026, maybe come back later, that kind of stuff. So it's still the biggest the biggest bottleneck. There is still the biggest bottleneck. Supply chain in general is the bottleneck in space right now. Everybody has projects, there's money in the system, VC money, client money, whatever money. If you go to talk to suppliers, they're busy. They tell you they'll do stuff and they don't do it, and and then you come, somebody pays more and then you come second. And the biggest of the suppliers that is a big bottleneck is still the launch.
You have India, right? ISRO in India there.
We do direct to geo, so our thing is a bit special, so that's why we need you. Yeah, to go up. So my company has like a very special need in terms of launching. I think if you go to Leo, then it's probably less severe, but it's still the biggest bottleneck. Still the biggest bottleneck.
But people take care of it. Like at ESA, we try to talk about something else. We try to talk about space for climate, we try to talk about exploration, and every time our delegates and member state, your governments come back to us and say, what about the launchers? Because it's still a crisis, right? And we're working on it. Everyone wants like Ariane 6 to arrive, Legacy to come back to launch, and micro launches.
I don't want Ariane 6 to come back. Enough of my tax money. We don't want private players. If they can.
We are working on it. Like ESA should be placing the first contracts in anticipation to those micro launches already this year. That's part of my job to try to be to stimulate to ensure that ESA is like willing to encourage those, and then we'll see which of them are sustainable both from technical and economical point of view. But yeah, we are watching at like 12 quite serious projects in Europe that should be flying in the next 4 or 5 years at the latest. Some of them starting already next year.
Yep.
So hopefully that will happen, but that's small satellites in LEO for most of them. So I'm not sure it will solve your problem in the short run.
I like to have big problems because then solutions are also big.
Any other questions, comments?
Well, 4 or 5 years for the launchers, the NewSpace Spirit, that's quite far away. Huh?
I'm ESA now, so I have to make some margins here. Yeah. Some of my colleagues will tell you that it will be 2030 plus. I'm among the optimists. But, no, but like
when I see the speed of agile improvement we have on our products, 5 years is wow.
No, but there was, I mean, like, among the 12 that I mentioned, because I don't want, we're kind of a discussion with that, but we don't want to focus on the one that will be ready next year. So we have a couple of names, especially in Germany and some of them in UK, that probably be next year. But like, we want to wait. We don't want to say, okay, this one is ready, so it will be our new micro champion in Europe, because then you make the same mistake again. Like, what about the one that could come 1 year later or 2 years later, but would be cheaper?
I think the mistake is to look for a champion.
Yes, that's it. So, but then if you don't have a champion in the market to sustain several actors, so that's your job now.
Yeah. We are the market. Maybe a general comment. I'm not sure if it's a question, and maybe it's more of a question regarding the satellite OS. Okay, so my experience is that in the space market, people tend to do everything still because there's not enough supplier, is the shortage and everything. And it's not clear to me when this market really stabilize, which I hope will stabilize around, people who use space, people who are manufacturers, who assemble, like the car industry. And then some people who will put some kind of a software that any third party can use. Is that really what you want to do?
Yeah, I mean, that's part of it. And I mean, I believe that the whole concept of companies doing everything is not a good concept, because it leads to random satellites who may either have a fueling port or don't. And if they have one, it's not standardized. So I think that, I mean, right now, the satellite industry is, on one hand, fascinating, on the other hand, at a very early stage of development. So if I mean, and that's a big if, because we may never get there if people pollute space with all kinds of things. But if, like, I think humanity needs to come up with ways for companies to specialize, for standard solutions to appear, and that's what we are trying to do. So we believe that having a standardized software platform can add significant value, because you will have the ability to update software exactly this. I mean, let's assume you want to develop software for a satellite. Well, it has to run on a particular satellite, so you need to learn about the satellite. That's not efficient.
That's exactly
so if there's a standardized platform, you know that this is the format I need to use, and it can go up to any satellite. So I believe that having specialized companies offering specialized solution. I mean, Lucy's company is a very specialized company. She has a very well-defined offer, and she has a good chance to be really strong in that. Companies who do everything, today they survive. And they do everything because sometimes they don't have solutions. I mean, when we are talking to those manufacturers of satellites, they say, well, we had to develop our own operating system because there was no alternative. So the moment alternatives start to show up, people will say, well, actually, I have an option. Maybe I should not develop it. Maybe I should use that option. It has some benefits. It will take time. But I think that's in an ideal world, and we are not in an ideal world. So is it going to happen? I don't know. But in an ideal world, There will be some standards, there will be simplified processes. And for me, this is what NewSpace is about. It's making it accessible for a number of users, making it accessible for businesses. We are not there yet, but the movement started. Will it get there? I don't know, but
I think it will get
but I mean, if we don't try, we'll never see. So we say, oh, well, we'll just give it a try, and we hope that we are able to make a small dent. And if there are other companies like us, I mean, we need more specialist companies to try to solve solutions in a reasonable way. I mean, we are doing this because we believe that there is a problem about security. It's not about because we want to be the richest company. I mean, we are not going to make a ton of money of this. I mean, this is not a super attractive business solving cybersecurity for satellites. There is a problem. And when I'm talking to companies who build satellites, they tell me that security is one thing that keeps them up at night, because it's very clearly understood by the industry that it's not very secure. And it's like, you know, people said in the past, hey, it's up there, nobody's going to hack it. Well, that's not necessarily the case. So I think we need to do this. It has to be standardized. It has to be user-friendly. And yes, that's exactly what Tarides is trying to do.
Thanks.
I think the time is to conclude. If there are no more questions, I would like to really thank the presenters and all the participants. I mean, this was a great discussion, and I mean, I'm always sort of humbled if I see the really cool stories, the kind we heard from Lucy and Adel. I mean, our story is way less exciting, but I think it was a good discussion, and thank you so much for presenting. The session was recorded, so if anybody wants to get the recording, please reach out to the INSEAD Alumni Association, because they will be sharing the file. And also, if you are not belonging yet to the Yammer group of related to NewSpace, there is a chat group where people exchange questions, ideas, whatever. Feel free to join. And yeah, thank you so much for being here. And for the people who are here, you have the possibility to go for drinks if you like. So if you are not here, feel free to have a drink, and cheers to all of you.
Thank you.
Thanks very much. Have a nice evening, everyone. Bye.
Thank
Ciao
you.
tutti. Thank you.
Thank you very much. It was
Thank
really
you.
great. Thank you.
Bye-bye.
The drink.